then again, it's a nice illustration of the kind of question on one of this side that will appear on the exam. Furthermore, it's also a nice illustration of the case studies you'll be working on. Maybe the case studies are a bit more advanced, a bit more extensive, but the ideas are quite similar. So for that reason, I think it's a good idea to discuss this example now. And okay, what are we talking about? Well, the application is in refinery of crude oil, and it's essentially a production planning problem. Namely, we need to plan for the production capacity of next week. And the thing is that we buy crude oil from two countries, A and B. As we'll see, that brings different qualities of crude oil. And our refinery can produce that into gasoline and fuel oil. And of course, to make it interesting to us, in this particular course, is that demand for those products will be uncertain. So that's indeed typically an application that we might be interested in. What do we know? Well, most of the data is deterministic. In particular, the price of crude oil, we assume to be deterministic, which in practice is maybe not true, but that's an assumption. And, well, unit costs are 2 and 3 from the respective countries. And as I mentioned, the quality of those products are different. In fact, 1 unit of crude oil coming from country A can be refined and then brings 2 units of gasoline and 3 of fuel oil, whereas apparently the quality of the product coming from country B is higher. It brings substantially more gasoline and also a little bit more fuel oil. But that's also reflected in the prices. Right? So the other thing is that, well, we cannot produce an infinite amount. We have a limited capacity in our refinery. During a week, planning period, we can produce a maximum of 100 units of crude oil in a process. Okay. The more interesting part, well, is indeed the modeling of the uncertainty. We will assume that demand for those two products, so gasoline and fuel oil, are random and that they are described by normal distributions, and we will assume that those distributions are independent. And that's an assumption, and it's thinkable that that's not really justified, but for now we'll make that assumption. And in an extensive study, that's typically one of the things you analyze. This assumption valid. Okay, the problem is that we need to decide now on the amount of crude oil that we buy from those two sources, those two different countries, A and B. We have to decide before we learn what the actual demand is for our products. And the assumption is that our decision that we take now cannot be changed. Or if we decide now to buy a certain quantity from country A, that's actually what we get. Same for country B. If you know anything about the oil business, that's not from the practice. Those oil tankers that are floating on the ocean, they change ownership several times between departure and arrival. But this is simplification. We assume that. Okay. Given that demand is uncertain and that we have this decision already in advance, it may happen that we're not able to satisfy demand by our own production. And that's why we also model another opportunity, namely the possibility to buy those two end products, gasoline and fuel oil, in the market. But they will be more expensive than if we cover it by our own production. And that's reflected by the unit prices, 2.2 and 3.3 respectively. And given the structure of the problem, we aim at minimizing costs. And those are, of course, direct costs for buying crude oil. On top of that, we get the expected cost associated with meeting demand. In particular, not meeting demand brings additional costs. Problem is clear? Okay. So, in terms of a model, here are the ingredients. Like I said, it's going to be a two-stage problem. We have a couple of decisions to make, namely, naturally, first stage decisions the amount to buy from the two countries. Recourse decisions or second stage decisions will be to compensate for infeasibilities, that is, shortage with respect to demand. Cover that by our recourse decisions, buying gasoline and fuel oil in the market. We have random parameters, in particular we have two to model demand. Other parameters I have already discussed. And we have a couple of constraints. Namely, the first stage constraint is on our capacity. Whatever combination of amounts we buy from those two countries, it cannot be more than our production capacity. So that's the constraint in the first stage. And we have in the second stage a number of constraints, namely two, for each of the two end products, telling us that by the means that we have available, we should cover demand. All right. Of course, we have non-negativities on the decision variables. And this is our objective. Where should we comma here? And my question to you is to write down the two-stage recourse problem in all glorious detail. In particular, write down the second stage problem and its value function. That, of course, is the important ingredient in our model. I'll give you a couple of minutes to do so. Making progress or just hopelessly lost? Who's almost there? Raise your hand if you're done. Does anybody have troubles writing down the first stage of the problem? That is, the immediate cost as in the objective, and second stage. How to formulate it. Final call. Anybody? No? Then maybe we should proceed and discuss my solution, which looks like this. Indeed, I chose to write it down in the compact formulation that is involving such a recourse function Q, expected value function Q, which appears in the objective on top of the immediate or first stage costs, which are just the unit costs for buying from the two countries, A and B. Okay? The first stage constraint says there is a limit on the production capacity. And we have non-negativities, so that's it. The interesting part is, of course, in the details of specification of the recourse function Q, which as usual is the expectation of some underlying value function, which depends on our first stage decision X and the realization of the random parameters omega. And that's all captured by the second stage linear program, which involves two variables, namely one decision on buying an additional amount of gasoline, and similarly for fuel oil, depending on whether or not demand for the product is higher than what we produce. And what we produce is, of course, a function of what we bought in the market in crude oil. And we know that's that technology matrix that specifies a unit of oil from the respective countries brings a certain amount of the end product. That's spelled out over there. So, in addition, we have non-negativities, and that's then the full second stage problem. Now that it's given to you, do you all agree that this is a correct formulation? Where did you go wrong? What was the difficult part? Or maybe for another reason, where did you go wrong? Anything in arriving at this formulation that is a surprise? Probably not. Just that you're not that talkative. Okay. Then I have another question for you. What can we say about the recourse structure of this second stage problem? What are relevant questions? What do we always want to know about the recourse structure? Is it sufficiently expensive? Is it complete? And, well, maybe is it a particular special case that we recognize? Anybody? One question at a time. Is this sufficiently expensive recourse? I see several people nodding. You're right. Why is that true? I just wish you didn't move, right? Why is it so? Yeah. Cost coefficients are positive, end of story. Next question, is it complete recourse? What was the notion of complete recourse? Or just any realization of the right-hand side in this problem, we can find a feasible solution. Can we? The answer is yes.